Hi, welcome back. I hope yesterday wasn't too much information. We're going to continue on doing some more implicit differentiations and add a little bit more to it. So just keep going with us. Ask questions in the comments if you are having trouble with it, okay? So here we go. Next example. If we have x squared y minus y e to the x equals cosine x. Can you find dy dx? Find the derivative. Okay, and if we did not have differential or implicit differentiation, this would almost be impossible for us. Okay, do you notice two product rules? Keep your eye out. I'm going to keep warning you. Product rules are showing up everywhere. Okay? I'm going to do two separate ones. For the first one, if u equals x squared, du equals 2x dx. Very good. If v, that does not look like a very pretty v, if v equals y, what does dv equal to? Yep, 1 dy. That's my first. Okay. I'm going to do a second one in green. Okay. I'm going to keep it over here on the side. If u equals y, we've just done that. Du equals 1 dy. If v equals e to the x, what does dv equal? E to the x, what did you take the derivative of? Based on x, dx. So it's e to the x, dx. So those are my two product rules that we will use. So the pink one, first, d second, plus second, d first. Okay, don't forget that. Minus, remember this parentheses. Okay, when there's a negative there, because I didn't put a negative with my piece. First, d second, plus second, d first, equals, now cosine x is not, it's not a product rule, but what's the derivative of cosine x? Yeah, is it negative? Yeah, and don't forget our differential this time, Miss Evans. I know. These are getting very long. Yes, they are. It's okay. So now that's our first step. First step is the same every time. Okay? Take the differential of every piece. Second step, what are we dividing by? Yeah, dx. So I'm going to divide by dx. Divide by dx. Divide by dx, divide by dx, and divide by dx. Every term I'm also going to distribute that negative 1 when I simplify, okay? But I have some dx's over dx, dx over dx, and dx over dx. I'm going to go ahead and cancel those. In my third step is to simplify, so I've already started my simplification process, I guess. All right, so here we go. I'm going to simplify and rewrite. I've got an x squared dy dx. Plus, now this right here, I probably would rewrite. I probably wouldn't write y to x. Mathematicians kind of don't like that. So is it okay if I write 2xy? Thank you. Minus y e to the x minus e to the x dy dx equals negative sine x. So that's my simplification. I have two dy dx's that are left. They're on the same side of the equation. That's good. But I need to get the other stuff over. Okay? So I'm going to have to subtract 2xy and add a y e to the x. Okay? So I'm going to go ahead and do that 2xy plus y e to the x. So these are gone. Everything else is together. So I've simplified. Now I'm rearranging and solving for dy dx. If you can do it, go ahead and pull it out. dy dx, parentheses, x squared minus e to the x equals. Now, my right side, I don't like things to start with a negative sign always, so I probably would start with my one positive piece, if that's okay. It should be fine. Y e to the x minus sine x minus 2xy. That is all on the right side. Gonna have to scroll. These problems are gonna take time and space on your paper, just so you know. Now I'm dividing by x squared minus e to the x, dividing by x squared e to the x. There's a subtraction sign in there. Yes, there is. Okay, so all of this is my derivative, dy dx. Okay, because these are going to cancel. Simplify, solve for that piece. Not too bad. I know I skip a few steps. Hoping we're close to the end of the year, you're following along with me. Okay, so that's pretty much what we did yesterday. Watch that product rule. It's going to come in to play a lot. Okay, so when we talk about derivatives, generally we're talking about the slope. Generally we've talked about the slope. We've talked about a tangent line. So if I say find the slope of the tangent line, what are they talking about? Yeah, it's the derivative to the graph of. So they're going to give you a graph. X, they give you a simple. They start out simple. And in this case, before, they just gave you an x equals. Well, they can't do that anymore. They have to give you a point. Okay, so they're going to have to give you an x and a y. Okay, so we're still going to solve first step of everyone, finding the tangent, the slope of the tangent line, okay, or the line tangent to. Tangent is always going to be the derivative, okay? So can we find dy dx? Yes, so that's what we're trying to solve for. Okay, so they're going to say it in different words. Okay, so here we go. We're taking our equation, so I'm going to rewrite it over here. X squared plus y squared equals 2. First step, finding differentials. Go to each piece. What's the differential of x squared? Yeah, the derivative is 2x. Put your differential piece there, dx. Plus 2y dy equals, what's the derivative of 2? Correct, it's 0. We want to divide by whatever's in our denominator, so we're dividing by dx. Those cancel. Oh, we got to divide 0 by dx. Sorry. And then we're going to solve for dy dx. Now, I'm going to go ahead and pull it out. 2y dy dx equals 0 minus 2x. Okay. Solving for dy dx. It's going to equal negative, so I'm dividing by 2y. Dividing by 2y. My 2's are going to reduce to a 1. I'm going to have a negative 1. Actually, I don't even want to put that negative. The 1 there. X over y. So that's my slope, right? That's the equation, that's the tangent of that. But now I have a point. So now this is going to come into play. After we found the derivative, we're going to plug in, right here, a point of 1, 1. So x is 1, y is 1. So dy dx at the point 1, 1 will simply be negative 1. Okay? What's the slope of the line at the point 1, 1? The answer is negative 1. That's the slope of the line. Okay? Because again, you recognize this as a circle. So x is 1, y is 1. That's the slope of the line. They do a nice, lovely equation. Okay? They also say, hey, we could put this in a graph. Okay? Do you want to see what it looks like in a graph? Because next, the question they're going to ask is in a graph. Okay? And they don't even change equations. So let me just go on and not scroll. All right, so I'm going to take the same equation and I'm going to draw a circle. Okay? And I'm going to draw, I probably should have drew my lines first because, of course, that won't be centered perfectly. That one is not bad. So I'm going to take this line, I'm going to move it over, hopefully closer to the center. Okay. All right. So, an equation of x squared plus y squared equals 2. Okay, that's a circle. Where's the center? The center of the circle. Yeah, it's at 0, 0. Because there's no other x minus something or y minus something. What is the radius? It's x squared plus y squared equals r squared. Okay. What is that squared? A little tricky. It's a square root of 2. Okay. So could I find the point right here? What's the radius? Okay. The x is the square root of 2. The y is 0. Up here, could we find that point? Yeah, it's 0 and the radius. Here, it's negative square root of 2. 0 and here, 0, negative square root of 2. So we can find points going all around that circle. Okay? Now they ask you, find the points on the graph of x squared plus y squared equals 2 where the tangent line is horizontal. So the tangent line is horizontal. Oh, let's back up just 1 second. The one we got where it's 1, 1. Okay? Does it make sense that that slope is negative 1? Okay? That slope, or that m, is negative 1. Okay? That's the point 1, 1. The problem we just did. Okay? Now they're asking for what point is it when the line is horizontal? The tangent line is horizontal. Well, you have to remember, well, what's my horizontal line? Okay? We could also find where's the slope 0. Okay? Because those are my horizontal lines. They have a slope of 0. Okay? You can go in and put, well, that would mean the x's are 0, all this stuff, and you get these 2 points. 0 square root of 2 and 0 negative square root of 2. Okay? So you would plug in 0. So you can go back to the derivative, negative x over y, and you're setting that equal to 0 because you know the slope must be 0. Okay, so if we wanted to look at it, you take the derivative and you set it equal to 0. Okay? Well, the only way this can equal 0 is if x is 0. So then we go back to our equation, x squared plus y squared equals 2, and I would plug in x equals 0. So 0 squared plus y squared equals 2. So y squared equals 2, take the square root, y equals plus or minus the square root of 2. Okay? Now, if we wanted to know the vertical lines, I'm going to try one more color on here. We want to know what point is it vertical. Okay, so what is our slope when it's vertical? I'll try to move just this. I'm going to move that over just a touch. Okay, so vertical lines have a slope of undefined. Okay, so again, I'm going back to my slope, undefined, meaning we're dividing by 0. Okay, so then my y's would equal 0. Okay? So then I'm going to go x squared plus y squared equals 2. So then I have an x squared equals 2, because 0 doesn't really matter. X is going to equal the plus or minus the square root of 2, which we have right here. Okay, some of it's just knowing logical sense. Okay? Sometimes they're going to give you multiple things. Here we go. Last problem. Let's hopefully have a shorter video than we did yesterday. That was a little bit long. They keep the same equation, which drives me crazy. Find dx dt. X and y are both functions of time. Can you find dx dt? Well, we've already found the differential of everything, so it's probably already on your paper. So I'm just going to write it 2x dx plus 2y dy equals 0. So if I'm solving for dx dt, I'm dividing everything by dt. Okay? Does anything simplify and cancel out? No. But I want to solve for dx dt, so I'm going to get it by itself. I'm just going to leave this out here. Equals negative 2y dy dt. Divide by 2x. Divide by 2x. So dx dt equals negative x over y dy dt. Okay? We've solved for dx dt. Now we're going to solve what is dx dt at the point 1, 1. So now we've got this. Now they're going to give you a point, 1, 1, and they're going to tell you what the change in y over the change in t is. So they give you dy dt equals 7. Okay, 7 units, whatever it is, the change in y over the change in time equals 7. Can you solve for dx dt? So I'm going to take this equation, dx dt equals, and I'm going to plug in my points and my information. So I've got a negative x over y times 7. So dx, the change in x over the change in time at point 1, 1, is negative 7. Okay? So they will give you those changes. Okay? The change in x over the change in t, or change in y over the change in t. So that is what we're going to end with. Implicit differentiation. We are going to do some problems. We won't have another video tomorrow. Your problems will be due at the end of the day. So lesson 34, problems, will be numbers 2 through 16. Okay, don't let the product rules slow you down. Okay, I think everything else should be self-explanatory. We've had problems like this before. Let me know if you're having any trouble. Have a great day and have a great, happy Easter. I can't wait to hear all about what you guys have done. I can't wait to get back together. We just need to have a little chit-chat sometime. That's what we'll do next week. Love you guys. Have a great weekend. Bye.